Okay, so we're going to now be looking at the same solving rational equations, but maybe with a little more difficult denominators. So in this first problem, we see an equation, and first I'm going to state the restricted values. In order to do that, I do need to factor this denominator, which is also going to help me with my LCD. So when I look for my restricted values from this x plus 5, which is in both of these, I know x cannot equal negative 5. And from the plus 3, I know x cannot equal negative 3. So now we're going to start to identify our LCD so we can make that LCD on all the fractions. So when I look, my LCD, we need an x plus 5 and an x plus 3, which if we multiplied it out, we can see from that second fraction is x squared plus 8x plus 15. So my first fraction is missing the x plus 3. My second fraction is missing nothing, and my third fraction is missing the x plus 5. So we're going to multiply this out. So in my numerator here, I have x squared plus 1x, or just x, plus 3x plus 3 over x squared plus 8x plus 15. And I'm not even thinking about multiplying that out because I know from over here that that's what it's equal to. My second fraction, we're just going to repeat what's there, just rewrite what's there because we don't need to change that denominator. So I'm going to write it multiplied out. And then the other side of the equation, we have 9x plus 45 over x squared plus 8x plus 15. So I'm going to combine those first two fractions together, which is going to give me x squared plus 4x, and we'll combine these two, plus 21 over x squared plus 8x plus 15 equals 9x plus 45 over x squared plus 8x plus 15. So now that we finally have that common denominator, one fraction on each side, we can multiply by the LCD over 1 on both sides. And that will cancel out our denominators. And we're just going to have this more simple fraction or simple equation to solve. So I am in a room where I can't scroll down on this and create more room. So we're going to see how this works. X squared plus 4x plus 21 equals 9x plus 45. So I'm going to move that 9x and the 45 over to the other side of the equation, leaving me with x squared minus 5x minus 24 equals 0. So I'm just going to draw a separator line. As I said, I don't want to restart the video, and I don't really have the ability to scroll down because of the way the smartboard is set up. So I have x minus 8, x plus 3 when I factor this one, which is going to give me solutions of 8 and negative 3. So this is our first problem. We've talked about it, but it hasn't come up yet, where one of my restricted values is an answer, which means that I have to cross out that answer, because even though it worked when I solved, basically if I was going to plug that negative 3 back in my original equation, I would end up with an undefined equation, right? We can't divide by 0. So my only answer is x equals 8. So let's look at the next page. And you could definitely try both of these. I'm going to go a little faster, but I want to kind of show you work for these. But you could definitely, especially B. C brings in something that's slightly different that might be a little trickier. So here, first off, hopefully you paused it and tried it yourself. We can't have 0 or negative 4 because of my two denominators. My LCD is x times x plus 4, which when multiplied out is x squared plus 4x. So we're now going to multiply by what's missing on each fraction. So my first fraction is missing the x. My middle fraction is missing the x plus 4, and maybe I should have rewritten this, but I'm just going to leave it like that, and this one's missing the x. So now I get x squared over x squared plus 4x minus x plus 4 over x squared plus 4x equals 2x over x squared plus 4x. So looking further, I need to distribute my negative sign. So I'm going to make this positive, negative, and then negative. So I end up with x squared minus x minus 4 over x squared plus 4x. So now we're one fraction each side, same denominator, multiply by that LCD over 1 on both sides. Cancel. And we have x squared minus x minus 4 equals 2x. So I see I have another quadratic. I want to set it equal to 0 so I can factor. Now, just a side note, if you had forgotten to distribute your negative up here, you would end up with something that doesn't factor. Now, if this is a test, usually we give you ones that factor. We're not going to give you a lot in quadratic formula on these types of questions. But if you're stuck on a test and you can't find your mistake, you will lose a lot of points if you stop here. You need to continue solving, whether that's quadratic formula or factoring. You need to make sure you can get to some sort of answer for as much credit as possible. But this one does factor. So that's -4 and +1. That works for that adding and multiplying, giving these solutions of +4 and -1. Now I look up here, I would have to cross out -4, but I have +4 as an answer. So both of these are fine. And those are my solutions to that equation. So looking at the last one we're going to notice maybe not right away, but we're going to get into a situation with a -1 when I see this 2 minus x here. So first off, I'm going to factor my denominators. So x plus 6, x minus 2, and I'll work on restricted values. So here it can't equal a -6. Here is a +2. This would also be -6. And here 2 minus 2 is 0, so we would also get +2. So now as I look at my LCD, right now it looks like I have 3 different factors, x plus 6, x minus 2, and 2 minus x. But we know if we take this denominator and factor out that -1, that's going to make the x term positive and the 2 negative. And then remember our little trick, we can move a negative sign to the top of the equation, or top of the fraction, sorry about that. So if I move this up here, I have -1 times -1, which is going to make that a +1. So I'm actually going to rewrite this. And actually move it over. Looking forward to the fact that I'm going to have to multiply by some things. So that's +1 over x minus 2. I'm just going to rewrite the rest of the equation. If I was doing this, and I wasn't showing this for a video, I might just, keep it kind of messy and work on the top at the same time, but this is fine. So LCD now is x plus 6 and x minus 2, which we know is x squared plus 4x minus 12. First fraction is good. Second fraction is missing x minus 2. And the third fraction is missing x plus 6. So first fraction stays. Second fraction, we have some distribution here. So I have x squared minus 2x minus 1x plus 2 over x squared plus 4x minus 12. And over here we have x plus 6 over x squared plus 4x minus 12. Combining our two fractions together, on the one side we get x squared minus 3x plus 6 over x squared plus 4x minus 12, x plus 6 over x squared plus 4x minus 12. Same denominator, multiply by it to get rid of it because we're solving an equation. And as I go over this one, a common mistake after you learn how to do the equations is to cancel out the denominator when you're adding. But what I'm doing right now is the multiplication property of equality. So if you don't have an equal sign, you cannot do this. You can't just get rid of denominators when you're adding. So we're down to that quadratic equation again. So I have x squared minus 3x plus 6 equals x plus 6. And I am going to subtract on both sides. So I have minus 6, right? Because if we have the x squared, we're going to need to factor. Here, my 6 actually cancels. I'm going to take this problem up here to finish it. So I have x squared, negative 3x minus 1x. Sorry about that. That looked like a plus sign. My smartboard's slightly off. And I'm messing it up worse. So let's just erase it and rewrite it. Okay, so negative 3x minus 1x is negative 4x. So this is a GCF factoring, right? We can take out the x from both terms. So I get x equals 0 from the monomial factor. Really, smartboard is off. And x equals 4. So let's check our restrictions. We have a negative 6 and a 2. These are both fine, so my final answers are 0 and 4 for that one.